G'day everybody and welcome back. So long time viewers would remember I built this tailstock chuck that hasn't got a chuck on it, but it normally has a 160mm 4-jaw chuck on it, which is currently on the rotary table. A little while ago a viewer in the US contacted me, asked if I had some plans and so on, and I did. The plans originally come from Max Grant at Swan Valley Machine Shop. I gave him the plans and he was pretty keen and he redrew them in CAD. So, done a good job too. And then a few days ago, a parcel arrived at the door. A 130mm 3-jaw chuck from Hare & Forbes arrived. It's a Toolmaster brand. I had no idea it was coming. It had me bamboozled for a minute. So I contacted one fella I thought that may have sent it, and he said, no, I don't know nothing about it. And I didn't realise on the bottom of the box was the invoice. And on the invoice, there was a note from the viewer who sent this in, so truly appreciate it. I probably have only used this twice since I built it. I could have used it numerous times, but the chuck seemed really, really heavy on that tailstock. As soon as you let the lock go, the tailstock just wanted to bounce forward. It was as heavy as buggery, and it was a pain to use. It's probably why I haven't used it, and I don't think I've even used it on camera, bar the test cut. But the viewer obviously picked up that it was mile heavy, so he decided to send me this one. So what I'm going to do, I'm going to revisit the project and build another backplate. I'll use the original spindle, and I'll be able to run the smaller chuck, which then I may use it a bit more in the future then too. So I've got a piece of 3/4 plate or 19mm plate to make the 130mm section to suit this chuck. This is going to be the slug that'll end up being this side of it. Carry the bearings in it. Go over to the lathe and start smashing it out. Okay, I wasn't really intending to film this build, but then I thought it might be interesting to see the comparison between the last time I built this piece and now, see what the accuracy is like. Probably guaranteed now I said that I'll screw it up, but this is already to length, just needs a 40mm bore in it now and a weld prep put on the end. Okay, now this 40mm diameter isn't a crucial diameter at all. I'm not sure what material this is, but by geez, that machine's nice. Anyway, I'm at about 30.5mm there at the moment. I'll bring this back when I'm getting close. Rightio, I've got 39.02. You can hear that dunny budgie. Listen to him buzzing around here, dirty mongrel. Okay, so the bore is out to 40mm or as good as, and I've just run a little chamfer tool around there, deburring tool. From this face back 20mm has to come down to 70mm. Okay, we'll make this the last cut. Uh, 70.03.5, close enough. I've got to cock it around 45 degrees and put a weld prep on here. I could do it by eye, but just do it nice and neat, I reckon. Be much better. Nearly good enough. So this piece can come out now, and I put the 4-jaw up. Okay, I got this set up in the 4-jaw. You see the scribe mark. I think you can see the scribe mark where it's 130mm, same as the chuck. So I've got a bit of material. I'll probably hack some of this off with a grinder later. But I want to put the bore in, then I'll face it off on one side, clean it all up. Anyway, I'll put the bore in to suit the 70mm. So it's a press fit, and then go from there. Okay, so the biggest drill I've got in Morse taper 3 here is 1 3/4 inch. Just doing a fair bit of jumping there. I might put a little bit bigger pilot hole in. Seemed to handle that 1 3/4 inch drill quite well after I put that big pilot hole in. And I think the reason was it's got this funny grind on the end. I didn't grind this tool, it was like it when I got it. But I think that first pilot hole was sort of catching up before it got to the full cutting edge here. Right, I'll start boring some of this out. I was going to get out the bore gauge, but probably really not worth it. It's only going to be a press weld fit. 69.99. Wants to start. That has to have a weld prep put on that too. That's the weld prep done. It should be roughly 8mm that flat, which it is. Just going to face this off now. I'm not going to face right out to the corners, but just face it off. Ain't that a terrible looking finish? It's not too bad. Plenty good enough to start with. I'll hit that with a TNGG insert once it's all welded up and in one piece, and doing the final cuts. That is ready to be welded together. Righto, we'll press it in, see what happens. There we go. It's got to be welded around here, welded around there. I'll do the welding off camera and bring his back when it's back in the lathe. Well, all I can say is I need a lot more practice welding. Pretty ordinary, but I'm just going to face this off down to dimension and face this off. Indicated it all in off this centre bore. This did warp a fraction, but that's to be expected. Anyway, just have to see how it all turns out. This dimension here, which is not that crucial, it says 75 on the plans. So I'll take a skim off it, get a measurement, and then I'll probably play around with this weld in the corner here, try and smooth that out, get a nice radius by eye, and then go from there. Oh, that's ugly, eh? That's not good. That was getting pretty ugly fairly quick, wasn't it? Okay, so I've had a bit of a fight with this, and I used stick welder obviously, and just used general purpose rods, but we have some hard spots. I did preheat it just with a MAP gas torch. I held there for ages and got it all warm before I welded it, but I don't know why. It's got hard spots. So anyway, I'm going to leave it as it is. Okay, so yeah, we're at 42.77 from this face to here. It's got to be back to 37. That's at 37. Got to break that edge and put the bore in for the bearing. Okay, so I'm up to putting the first bore in for the bearing. It's got to be 26mm deep and 51.98. So I'll keep boring away here and bring you back when I'm close. I'll give it a measure and see how I went. It should be 51.98. Lovely stuffed. 51.98. I can just feel it rubbing on the anvil. Anyway, you got to have a win one day. The other side isn't done yet, so we'll wait and see what happens then. So what happens now is take this out, turn the jaws around on the forejaw, clock it back up on this face, indicate here, and this face at the same time. So come in the back here and indicate off here and here at the same time, get it all running spot on true. I may even stick this bore and bar out at the moment and bore this out to 44, then I can use that inner bore as a register as well, because it'll be concentric to this bore. It's got to go out to 44mm regardless. How much you guys are going to see there, but that's out to 44 now. I'm pretty confident in that measurement without even measuring it. It's not a crucial measurement, it's just so you can get a punch in and knock the cones out, the bearing cones out. Okay, now it can come out and be turned around. I've got less than half a thou of run out on this dial. This is jumping a bit, this one, and it's the best I can get it. It's around about a thou. I can't get it any better. I've probably spent close to 3/4 of an hour on this, if not a bit better. Anyway, it's the best I can get it, so we're just going to run with it. Certainly gone into a bit of a hard spot there, isn't it? Lucky there's a chuck going on there. It's going to cover most of that crap up. I'll get it cleaned up and bring his back. Well, with the magic of television and a bloody great mess, it's round now, and I've got a hell of a mess to clean up. So that's going to do me tonight. By the time I clean up, that'll be enough for me. And I'll resume again in the morning. Right, bit of a drama going on here. Last night after dinner, I had a gut feeling something wasn't right, and I was correct. The overall length of this part is around 5mm too short, and I cannot for the life of me work out where I've gone wrong, which I don't think is going to hurt, so I'm going to keep going with it. If worse comes to worse, I will modify or attempt to modify the original plate. What I've got to do now is bore this out to 51.98, and then I've got to recess the back here for the chuck. Okay, I've just double checked the measurements and that is right. I've got to put a little chamfer lead in on this edge here. This is at 138.18, it's got to come down to 130, and then a 100mm register put in. The register is only going to be about maybe 2.5mm deep. It fits and it's holding itself on, which is a great thing. Well, this can come out now and have the bearings fitted. I do have to make up a aluminium spacer, which is going to be quite thin, in between the two bearings. And to be honest with you, I've got my doubts whether this is even going to be any good. This might be a total waste of time. That side looks pretty. That side looks crap. Some time ago, a viewer sent in some transfer punches. Sent a set of metric and imperial in return for a little job I'd done for him. Just going to go around with the transfer punch. These are going to be drilled and tapped down through the base here. So these are going to be drilled and tapped M8. Not a bad little chip come off then. A little bit of deburring to do on the other side, but I'll get these other two done and we're right to start assembling it. I've got it all together and so far it's a failure. And I have, because you've got to make up an aluminium centerpiece that goes between the bearings, and I don't know whether this material has moved or what's happened as I've machined it. I don't know what's going on, but that's far too much run out. I did put the chuck on it, and it's, by the time you put a bar in it, it's out a long way. So what I'm thinking of doing is modifying this one, which I didn't want to do because I wanted to keep it so I can put the 4-inch other 4-jaw back on if I ever have to. But I'm going to modify this one to suit that 3-jaw chuck. Anyway, you win some, you lose some. I'm just hoping I can make this one work. Anyway, time's only going to tell, but I'll probably do most of this off camera. So at least you've got to see this bit being built and fail. But yeah, I'll just get into it, and I've only got to clock it all back up really, really well, and then machine this shoulder back a little bit, bring the diameter down, and put a small register in to hold the chuck, and we should be pretty right. Got it all back together, and I'm starting to realise that I did waste a fair bit of time making the other one. I should have just done this from the start. I'm getting, with everything back in, the bolts torqued up, 0.01 run out. I'm pretty darn happy with that. I should have just done this from the start and not worried about saving this for the 4-jaw if ever I needed to put it on. So anyway, you win some, you lose some, but it was a good exercise in how to make a mistake. But I'm pretty happy with that. So I'll get the chuck put on and see what sort of results we get then, which could be a whole new different story. So on the body of the chuck, about 0.02, which I'm pretty happy. It's about the straightest thing I have. I think it's straight. I'm going to be cheesed off if this is out a mile. I'm just going to throw my hands in here and walk away and go and have a coffee. Who's putting bets on this? .03. I can live with that. I can't believe I blew all that time building that other one. I should have just done this to start with. Okay, found a bit of bar. It's about the only decent bit of bar I got. I haven't got any long stuff left. But a big advantage of having a tailstock chuck is if it's too big to fit through your spindle, you can set it up with the tailstock chuck, then turn a section here or wherever to put your steady rest on. Then you can put a centre in the end of it if you want to use a revolving centre if you've got work to do right on the end. It's just a big advantage to it, and this actually runs really, really nice. So I remember with that, and I had the 4-jaw on there, you had to clock it in all the time, and it wasn't real easy. It was sort of a real pain to do, but this here took about, I don't know, 30 seconds, if that. Just, yeah, it was set up. Everything runs true. So I'm pretty happy with that. It was a good result in the end. Well, it wasn't the outcome I wanted, but at least I've got a good tailstock chuck again. Now, after thinking about this for a little bit, and the run out that it's got, after I welded this and done the machining, it did sit in the lathe overnight. And whether the stresses have released out of this, and then I've gone in the next day or whatever and then finished the outer off, finished the register and that off. Whether that's the case, the stresses are relieved, and then it's not concentric. But I'm only surmising. But either way, it's no good. But I still enjoyed making it. That's the main part anyway. Even though it didn't work out to what I exactly wanted, still enjoyed it. Anyway, I hope you guys got something out of that, and I'm hoping tomorrow I'll be able to order the DRO for the milling machine, and I'm not too sure what's going to happen with the video next week, but just see what happens. Anyway, appreciate everybody watching, and hopefully see you all next week. Hooroo.